Hello, good morning. Um, Straight to business. The question is on linear expansivity, as you can see. The formula you are going to apply is linear expansivity represented by alpha equals to change in length, all divided by initial length L1 multiplied by change in temperature. Now, change in length, remember, can also be broken down to final length minus the initial length, which is L2 minus L1. According to the question, what was given, L2 is supposed to be the final length, which is 15.05 centimeter. L1 is supposed to be initial length, which is 15.01 centimeter, as it is. Now, change in temperature that was given, they said the metal was heated to a temperature rise of 60 degrees Celsius. So change in temperature is also theta 2 final temperature minus theta 1, but they didn't give us that, and we don't need to bother about it since they've given us the change in temperature as 60 degrees Celsius. Now, going by that, if you go and use the formula, change in length is equal to L2 minus L1. That gives us 15.05 minus 15.01, which is 0.04 centimeter as the change in length. Now, substitute into that formula that we wrote initially. Linear expansivity will then be equal to 0.04 change in length all over initial length, which is 15.01 centimeter, multiplied by 60 degrees Celsius. If you do that and do your calculation, it gives us 4.441 times 10 raised to power minus 5 as the final answer for the linear expansivity of that metal. I hope that is clear enough. Now go to question 2. Question 2 is about motion of an object or a car. As the question is, it said the car starting from rest accelerates uniformly and attains a speed of 80 meters per second in 30 seconds. It maintains this steady speed for another 30 seconds. When a body maintains steady speed, it means it is not increasing in speed. It is going at the same speed for some time. So that is what happens for another 30 seconds. It then slows down. When it slows down uniformly, that means it is retarding. You can also use it retards. It's the same thing as slowing down and trying to come to rest in the next 10 seconds. So sketch the velocity time graph for the motion of this car. From here, your graph will be velocity at the vertical axis, time at the horizontal axis. So when it rises up and goes to 80 meters per second, that is the first journey. When it reaches 80 meters per second, it did that in 30 seconds. Then it then moves at that steady velocity at 80 meters per second for another 30 seconds. That is the straight line showing the steady movement, the steady motion. Then it then slows down, meaning it retards, meaning it goes down and comes down to rest when it finally stops in another 10 seconds. That means the total time taken for that journey is 30 plus 30 plus 10 seconds, while the velocity for that journey is 80 meters per second as seen in this diagram, and this is just the diagram you need. Another question that could be asked from this, which is not asked anyway, is find the total distance traveled. Calculate the total distance traveled in the entire journey. This could be done. Maybe I will do another video and try and do that for you. So I think for now, this is what the question is asking. In the next video, I will do how to calculate total distance from this diagram.